Hello everyone and good afternoon. Am I audible? Please reply. Okay, so we will start with our today's lecture. Okay, thank you. So in yesterday's lecture, we have started with our first unit, overview of cloud computing. Okay, so we have seen the history of cloud computing last time. Okay, so in that we have covered the points like introductory part of our chapter, that is title and central idea, importance, and the chapter outcome last time. And then we have seen the history of cloud computing, that is started in the year of 1950s. Then it has continued to 1969 with ARPANET. Then 1970s with IBM released a operating system, that is VMs, virtual machines. Then in 1990s, how the journey has gone over there also. And then in 1997, the term cloud computing, which was coined by University of Texas Professor Ramanatha Chelappa, with new computing paradigm. And then in 2002, the Amazon, which has created the AWS, that is Amazon Web Services. Then in 2006, the Elastic Compute Cloud EC2, which was introduced as a commercial web service. And in 2009, the Google has launched it's a Google App Engine, and the services with Microsoft followed suit with Windows Azure. Then in 2010, the OneServe field service management software moved to the cloud. So this part we have seen in the last lecture, and we have started with the history of cloud computing last time. So now the next part we will see, and that is nothing but the evolution of cloud computing. So here the journey or the evolution, how it has taken into consideration, taken into the picture, that is shown with this particular graph. So the journey has started from here 1950s, so till date 2007 and onwards, the how it has how it is been considered, that is shown here in this particular graph. So here, as we know, the cloud technologies were empowering the enterprise or top MNCs to carry out their critical functions in a better environment, which will provide us the reliable support for standing or expanding their business without huge investment. So here we are decreasing the investment which are there from the organization's point of view, and giving a broader functionality to different clients of that particular company. So by implementing different cloud service models, there is sufficient potential for optimization of business processes and some adjustment to the changing market conditions. As we know, day by day the market conditions are changing. So whatever was there yesterday in the market, which is now we can consider as a past today, isn't it? So new very latest technologies are coming day to day in this particular market, and they are taking boom, they are taking a proper position in the market. So in this particular changing environment, we have to grab means like there should be sufficient potential for this type of changes, and to optimize your business. Optimize is what? In less and less memory, in less efforts, you are giving maximum to the market, maximum to your client. So this is nothing but the optimization, we can say. So companies can therefore create a flexible strategy for development with utmost usage of resources, different kind of resources, then minimal efforts for maintenance and efficient implementation of business activities over here. So in this particular evolution, the cloud computing is nothing but all about renting the computing services. Renting is what? Rental services, we know already. Okay, we are saying like I have given my house, I have given 2 rooms on rental. That means what? I am the owner of it, but I am giving those rooms to my say customers for some days, isn't it? So this is kind of a rental services. So cloud computing is also giving some rental what? Computing services. So this idea first came in 1950s, as we have seen the seen here in the picture only. The journey has started from 1950s. So in making cloud computing what is today, so 5 technologies played a vital role in this. 5 important technologies are coming into picture in this. So these are nothing but the distributed services and its peripherals, then virtualization, Web 2.0, service orientation, and utility computing. So these are the important ones. Which ones? Distributed computing, virtualization, Web 2.0, service orientation, and the cloud utility computing. And then after comes your cloud computing part, isn't it? So we can start with distributed computing now. Fine. So distributed computing or distributed systems. So already in last semester you have seen this particular subject. So it is the composition of multiple independent systems, but all of them are depicted as a single entity to different users, isn't it? So many at a time are working, but for the user it will be seen like a single user or single entity. So the purpose of distributed system is to share the resources and also use them definitely effectively and efficiently. So effective use of these resources is very, very important. You might have seen the examples of sharing uh, costly resources like printers, scanners, with multiple uh, re- machines, computers, isn't it? So distributed systems possesses characteristics such as the scalability, concurrency, continuous availability, heterogeneity, and independence in failure. So suppose, for example, any single machine is getting failed, it will not getting harm to other systems present in your network, isn't it? So this is nothing but the independence in failures. But the main problem with this distributed system was that all the systems were required to be present at the same geographical location, isn't it? So thus, to solve this problem, distributed computing led to three more types of computing, and they were mainframe computing, cluster computing, and grid computing. So in the graph, in this particular picture, we can see the second is nothing but your mainframe computing. So first part is distributed computing and second is nothing but the mainframe computing. So here in mainframe computing, it is mainframes which first came into existence in 1951 and are highly powerful and reliable computing machines. So these are responsible for handling large data such as massive input-output operations. So even today, these are used for bulk processing tasks. So even today, these are used for bulk processing tasks such as online transactions, etc. So these systems have almost no downtime with high fault tolerance. So after distributed computing, these increased the processing capabilities of the system. But these were very expensive. The mainframe computing was very, very expensive. So to reduce this cost, cluster computing came as an alternative to mainframe technology. So here the third one coming, and that is nothing but your cluster computing. Okay. So cluster computing. So in 1980s, the cluster computing came as an alternative to mainframe computing. So each machine in the cluster was connected to each other by a network with high bandwidth. So these were way cheaper than those mainframe systems. So these were equally capable of high computations. Also, new nodes could easily be added to the cluster if it was required. So thus, the problem of cost was solved here to some extent, but the problem related to geographical restrictions was still pertinent. So to solve this, the concept of grid computing was introduced, and which is there as a next step in this. That is nothing but the grid computing. So grid computing, so in again 1990s, the concept of grid computing was introduced. It means that different systems were placed at entirely different geographical locations, and these all were connected via the internet. So these systems belonged to different organizations, and thus the grid considered of heterogeneous nodes. Heterogeneous is what? Which are having different OSs, different configurations on their systems, isn't it? So to connect all such heterogeneous nodes, this particular grid computing came into existence. So although it solved some problems, but new problems emerged as the distance between the nodes was increased. So the main problems which was encountered was the low availability of high bandwidth connectivity, and with it other network associated issues. So if two systems are located with a far distance in between, so there may be chances of getting physical interrupts as well as network issues there. Thus, cloud computing is often referred as a successor of grid computing. Okay, then comes the term as a virtualization. So virtualization, it was introduced nearly 40 years back. It refers to the process of creating a virtual layer over the hardware, which allows the user to run multiple instances simultaneously on the hardware. So it is a key technology used in cloud computing. It is the base on which major cloud computing services such as our Amazon EC2, then VMware, Cloud or vCloud, etc. are working. Then hardware virtualization is still one of the most common types of virtualization. Then next is Web 2.0. 2.0 also we can consider it as. So Web 2.0, it is the interface through which cloud computing services interact with the client. So it is because of Web 2.0 that we have interactive and dynamic web pages. It also increases the flexibility among the web pages. Popular examples of Web 2.0 include Google Maps, Facebook, Twitter, etc. So needless to say that social media is possible because of this technology only. It gained major popularity in the year of 2004. Next came the service orientation. So the service orientation, it acts as a reference model for cloud computing. It supports low cost, flexible, and evolvable applications. So two important concepts in this were introduced in this computing model, and these were quality of service, that is QoS. Definitely we should give best quality to our clients, which also includes the SLA, service level agreement, and software as a service, that is SaaS, that we are going to study in coming bits of this chapter. Then came, yes, Aishwarya. Then came the utility computing. Utility computing, it is a computing model that defines the service provisioning technique for services such as compute services, along with the other major services such as storage, infrastructure, etc., which are provisioned on a pay per use basis. Pay per use means what? As many times you are using that particular system, that many times you will be paying for it. So it is nothing, it is the concept coming into the utility computing. And after that, the cloud computing came into existence. So here, the all these technologies we have seen now, all these technologies contributed to making of cloud computing platform. Okay, so this is nothing but the evolution of cloud computing. Next part is, so all these part we have seen just now. Next part is traditional versus cloud computing. So this kind of a question may be asked if you are having theory paper. Okay, what is the difference between traditional computing and cloud computing? So we will see all the points related to this. So traditional computing, it refers to the delivery of different services on a local server. Here we are using the local server in case of traditional computing. Whereas in cloud computing, it refers to delivery of different services such as data and programs through internet on different servers. Then here traditional computing, it takes place on physical hard drives and website servers. So physically storing of these on physical hard drives, websites was there in traditional computing, whereas in case of cloud computing, it takes place on third-party servers that is hosted by third-party hosting companies. In case of traditional, user can access data only on a system in which data is stored. Whereas in case of cloud, it is the ability to access data anywhere at any time by the user. Next is, in case of cloud traditional, it is less cost effective as compared to the cloud computing because one has to buy expensive equipments to operate and maintain the server. So as we are having different servers, so everybody's responsibility is there that to maintain those all servers. But here in case of cloud, it is more and more cost effective as compared to the traditional computing, as operation and maintenance of server is shared among several parties that in turn reduce the cost of public services. So whatever the agencies, then whatever different parties involved in maintaining that particular servers, okay, so it is the responsibility of them only to give proper service, give proper maintenance to their servers and all. So ultimately the cost effectiveness will be more in case of cloud. Then come next difference is here it is less user friendly as compared to the cloud computing because data cannot be accessed anywhere, and if user has to access that data, in another system, then he need to save it in the external storage medium, isn't it? But in case of cloud, it is more user friendly as compared to the traditional computing, because user can have access to the data anytime, anywhere using internet. So we can compare the what we can say, sending email for getting different kinds of updates from your friend, we can say, and at the same time sharing one particular file from the Google Drive. Consider both of these applications. So suppose I want to update one particular Excel sheet where I will be maintaining the records of 70 students from your class. Okay, so I will send the format that I want this data from my students, that is, say for example, name, first name, middle name, last name, your phone number, your parents phone number, then address, and say caste, SSC HSC marks, and all these things suppose I want. Okay, and I for that I will send one mail, I will drop one mail to you all that I want this data. So how will you going to reply that? So each and everyone will read that particular mail, update his or her record in that Excel sheet, and he or she will send that his or her own field Excel sheet to me, isn't it? So what will be the result? I will get 70 different mails. I have to open all these files. I have to not only open, but maybe sometimes I have to download them and then go for copy pasting. So this is one task, and another is I will share the Excel sheet, okay, with your roll number and name, and I will say you update your records in that particular file. Okay, so this is also one of the application. And then I may create one Google form which will in second I may get the reply from somebody that like in the Excel sheet, in the first name, middle name, he or she will be putting some numbers. For mobile number, the student is giving wrong data in that way. Okay, so what I will do is I will create one Google form, and through which I will collect the data. So which one will be more efficient, whether to go for emailing and collecting all the emails from all 70 students, or creating the Google form? So this is nothing but the user friendliness which we are discussing over here. Okay, then next is, it does traditional computing, it does not require any internet connection to access the data or information. But in case of cloud computing, it requires fast, reliable, and stable internet connection to access the information anywhere at any time. Then in case of traditional, it provides less storage as compared to the cloud computing. In case of cloud, it provides more storage space and serves as servers, as well as more computing power, so that applications and softwares run must faster and effectively. Then in case of traditional, it does not provide any scalability and elasticity. In case of cloud, it also provides the scalability and elasticity. That is, one can increase or decrease the storage capacity, server resources, etc., according to the business needs. So as per the business, I will increase the size or decrease the size. It will be up to the application only. And then next is it requires own team to maintain and monitor the system. That will need a lot of time and efforts in case of traditional. But in case of cloud service is served by providers support system or support team. Then in case of traditional, software in purchased individually for every user and required to be updated periodically. But in case of a cloud, software is offered as an on-demand service, which is nothing but the SaaS, software as a service, that can be accessed through subscription service. So this is the difference between traditional computing and cloud computing. Okay, getting the point? Any doubt in this? Then next point is why cloud computing? Why we should go for cloud computing? So here in this point, why to go for cloud, we will see the important characteristics provided by the cloud computing. So the first characteristic here is given. Basically, these 5 very essential characteristics are given by cloud computing, in which the first one is on-demand self-services. So what is that? So the cloud computing services does not require any human administrations, any kind of a human administration, so that users themselves are able to provision, monitor, and manage the computing resources as they are needed. Second is broad network access. The computing services are generally provided over standard networks and heterogeneous devices. Then rapid elasticity. Here the computing services should have IT resources that are able to scale out and in quickly and on as needed basis. Means whenever the need comes, that time only we can take them into service, otherwise not. So whenever the user require the services, it is provided to him and it is scale out as soon as its a requirement gets over. So whenever you need it, use it, otherwise it will be scaled out. So it is giving you the rapid elasticity. Fourth one is resource pooling. So what is that? So the IT resource, for example, the network, servers, storage, applications, and services which are present are shared across multiple applications and the occupant in an uncommitted manner. So multiple clients are provided with the service from a same physical resource. And fifth one is measured service. So that is the resource utilization is tracked for each application and occupant. So it will provide both the user and the resource provider with an account of what has been used. So this is done for various reasons like monitoring, billing, and effective use of resources. Fine. So this is nothing but why we should go for cloud computing, the 5 important characteristics. So you may be asked question in MCQ also, what are the different characteristics of cloud computing? So they are on-demand self-services, broad network access, rapid elasticity, resource pooling, and major service. Okay. So now coming towards the next part, that is cloud service models. So three important models we have to go through here in the figure. They are listed, that is SaaS, SaaS, that is nothing but the software as a service, then PaaS, platform as the service, and infrastructure as a service, IaaS. So here software as a service is mainly having use it kind of a where the services which are in use, you can use it. Then platform, here you can build with it, and infrastructure as a service, move to it. Okay, we will see them one by one. The first one is here, as per the syllabus, first one is listed over there as a infrastructure as a service, IaaS. So infrastructure as a service. So infrastructure is nothing but what? It will be considered basically with the hardware devices such as network devices, then visualize the server, storage, etc. So it introduces enterprises to a virtualization environment where the services facilitate cloud platforms and the applications to connect and function. So here IaaS addresses compute services in the form of set of virtual machines with combined storage processing capability as well as other related services and network connectivity. Then this empowers the multiple applications maintained by different cloud consumers to mutually share common physical resources such as servers and storage. IaaS offerings may include, it provides a pool of highly available processing units, utilization data, and change back data. Then consumers do not have to purchase the servers, softwares, data center space, or network equipments. Then consumers can lease such resources as a part of fully outsourced services. So some examples of IaaS products and the providers are nothing but the IBM Bluehouse, Amazon Elastic Cloud Compute EC2, GoGrid, VMware, RightScale, etc. So infrastructure as a service, IaaS, it is the service model that delivers the computer infrastructure on an outsourced basis to support various operations. Typically, it is a service where infrastructure is provided as a outsourced to the enterprises such as networking equipments, devices, database, and web servers. So that's why, as it is the sharing of hardware, so it is also known as a hardware as a service, that is HaaS. So IaaS customers pay only on per user basis. So whatever you are using, for that only you will be paying. So typically by the hour, week or month, it will be considered. Some providers also charge customers based on the amount of virtual machine space they are using. So it simply provides the underlying operating systems, security, networking, and servers for developing such applications, services, and for deploying development tools, databases, etc. So if we consider the advantages of IaaS, then they are nothing but the first one is it's a cost effectiveness. That means it eliminates the capital expenses and resources and reduces the ongoing cost, and IaaS customers pay on a per user basis, typically by the hour, week, or month. Then website hosting. So running websites using IaaS can be less expensive than the traditional web hosting. Then security. The IaaS cloud providers may provide better security than your existing software. And finally, the maintenance. There is no need to manage the underlying data center or the introduction of new releases of the development or underlying software. So this is all handled by the IaaS cloud provider only. So the various companies providing the infrastructure as a service are nothing but Amazon Web Services, the first example, then BlueStack, IBM, OpenStack, Rackspace, VMware, etc. Next is platform as a service. That is nothing but the PaaS. Platform as a service, it is a cloud computing model where the developers can develop, run, and manage business applications without the need to maintain the software development infrastructure. So cloud service providers can provide the developers with the resources such as development tools, infrastructure, and operating systems. Therefore, it significantly simplifies the application or product development from the developer's perspective because all the tools and backend management are provided by the cloud only. So this presents the enhanced flexibility and control for the consumer over their product. It also frees the developers from having to install in-house hardware and software to develop or run new applications. So PaaS offerings may include the deployment of the complete application, including custom-made platforms, then easier management of hardware and software applications, as well as hosting abilities, then better facilities for application development, design, testing, deployment, and hosting. So cost is an influential driver for the customers signing up for a platform as a service offering, as it is subscription based and gives you flexible pricing options depending on your business requirements. So the benefits of PaaS may include reduction in development cost, then increase in flexibility for the development process, decrease the server storage overhead, then flexible support for the development. Also, it supports multi uh, ten, tenant architecture and scalability. So some examples of this are Google App Engine, Windows Azure, Engine Yard, Amazon Simple Storage Service, that is S3, Force.com, Moso, etc. So we can say that PaaS is nothing but the category of cloud computing that provides the platform and the environment to allow the developers to build the applications and services over the internet. So PaaS services are hosted in the cloud and accessed by the users simply via their web browsers. So this PaaS provider hosts the hardware and software on its own infrastructure. As a result, PaaS frees the users from having to install in-house hardware and software to develop or run a new application. Thus, the development and deployment of the application take place independent of the hardware. So the consumer does not manage or control the underlying cloud infrastructure, including the network servers, operating systems, or storage, but has the control over the deployed application and possibly configuration setting for the application hosting environment. So overall, the application or the advantages of PaaS are nothing but it is firstly simple and convenient for the users. So it provides very much of the infrastructure and other IT services which users can access anywhere via a web browser. Secondly, the cost effectiveness. It charges for the services provided on per user basis, thus eliminating the expenses one may have for on-premises hardware and software. Then third is efficiently managing the life cycle. So it is designed to support the complete web application life cycle, that is building, testing, deploying, managing, and updating. And fourth is efficiency. So it allows for higher level programming with reduced the complexity. Thus, the overall development of the application can be more effective. So the various companies which are providing the platform as a service are nothing but the Amazon Web Services, Salesforce, Windows Azure, Google App Engine, Cloudbase, and IBM Smart Cloud. And next is software as a service. So in case of software as a service, software as a service refers to pre-built, functionally independent, vertically integrated, and universally available applications such as email system, human resource management, payroll processing, software testing as a services, data processing, and other application processes. So these are the applications delivered to and used by the customers as a service. So this SaaS, SaaS offering may include it's software deployed similar to the hosted service and accessed over the internet. Then the services regularly operate behind a firewall on a network and implement only on-demand usage. And thirdly, it implies a pay-as-you-go kind of a delivery approach. So with this deployment model, customers are generally looking to purchase functionality and pay for its use. So sometimes such services are available to the general public totally free of charge. For example, networking applications like Facebook, Gmail and its services, where the emails, attachments, photographs, data, etc. are stored on a remotely accessible server. So SaaS is a comprehensive warehouse where the services can be anything from inventory administration to the web-based email. Indeed, in some cases, it includes online banking as well as database processing also. So some examples of SaaS are nothing but Salesforce.com, Gmail, WebSphere, IBM, Microsoft Office, etc. So overall, SaaS is a way of delivering the services and applications over the internet. Instead of installing and maintaining the software, we simply access it via the internet, freeing ourselves from the complex software and hardware management. It also removes the need to install and run applications on our own computers or in the data centers, eliminating the expenses of hardware as well as software maintenance. So SaaS provides a complete software solution that you purchase on a pay-as-you-go basis from the cloud server provider. So most of the SaaS applications can be run directly from the web browser without any downloads or installations required. So the SaaS applications are sometimes called as a web-based software, on-demand software, or hosted software also. Advantages may include it's a cost effectiveness. So pay only for what you use. Then second is reduce the time. That means users can run most of the SaaS apps directly from their web browser without needing to download and install any of the software. So this reduces the time spent in installation and configuration and can reduce their issues that can get in the way of the software deployment. Then accessibility. So we can access the app data from anywhere. Then next is automatic update. So rather than purchasing new software, customer rely on the SaaS provider to automatically perform the updates. And fifth is scalability. So it allows the user to access the services and features on demand. So the various companies providing software as a service are Cloud9, Analytics, Salesforce.com, CloudSwitch, Microsoft Office 365, Eloka, Dropbox, CloudTrend, etc. So the next bit is cloud deployment model, but we are not going for that now. So do you have any doubt over here? So we will stop over here. You can put your attendance in the chat and then leave. In the next lecture, we will see the cloud deployment models. Those who have put the attendance, they can leave. Thank you.